This video is intended to be a quick start on PHREEQC, assuming that you have PHREEQC installed. From our previous video, we had a folder where we have all our database files. The database files are used to provide PHREEQC knowledge of the chemical properties that each chemical has, as well as their reactions. So as an example, if we click on PHREEQC.database, double click to open it, the first thing to note is that you will have to open it using a particular program. You can use things like VS Code, Vim, Emacs, your terminal, but I will be using Notepad since that's what I have, and I'll just have this enabled so that I can open it in the future. You can see the solution master species, which contains information about all the different elements, and you can also see the properties that are used for speciation. One of the things to note is that names for certain chemicals are not necessarily in their chemical name. So for example, halite is the name for sodium chloride. To run PHREEQC, we'll be using the terminal, but before we do that, we need a PHREEQC file. So I'm going to right click and just make a new file. You can name it whatever you want, and you can also remove the extension if you want. I prefer having a consistent naming system. So for example, I could name this tutorial 01, and to make sure that I or anyone in the future knows that this is a PHREEQC file, I can name it PQI for PHREEQC input. And yes, I want to change the change. If you do not see these extensions or these types being changed to however way you want to make it a type, you can click on View on Windows and enable the file name extensions to see the extensions as well as to modify them. If I double click and I run it with Notepad, I'm presented with a blank screen, and that's expected. The first thing we'll be doing is specifying the database. On PHREEQC, every command or every, environment begins with an all caps keyword or phrase that has been separated by underscores. So in this case, database is the keyword to specify the location for the database we'll be using. If you were to leave this blank, PHREEQC would still run and it would use the default PHREEQC.dat database. For this, just to give you a demonstration, I can use the Lawrence Livermore National Lab database. Enter. And the next thing I can do is I can specify a title for this. You don't have to specify a title, but I just want to show you a basic use of PHREEQC. So for the title, I'll say, let's say tutorial 1. So after this keyword, everything is the title, and the next lines will represent the next keywords. So I want to make a solution, and this will be our first solution, so solution 1. And after this, everything will be the name for the solution. So I can name it water with salt. With that, if we were to finish here, the solution would simply be just water, just 1 kilogram of water. However, I want salt, so I will add sodium, 1 mole of sodium, 1, and chlorine, 1 mole of chlorine. To better specify the units for this, that is that this is 1 mole of sodium or 1 mole of chlorine, I can specify units as moles per kilogram of water. Since this is 1 kilogram of water, these values represent 1 moles exactly. And just so you know, the W over here stands for water. If you were to use S instead, it would be kilograms of the total solution. I will stick to just water for now. There are other properties that you can specify, such as temperature, pH, other chemicals, the PE. I will leave this as it is, since this is going to be a very basic tutorial. The final thing that we will be doing is just saying end to state that this is the end of our document. I will save by pressing Ctrl S. I'll close. Since PHREEQC is a command line utility, we have to go to our command line. If you right click, you will not see any access to the command line. However, if you hold your shift button and then hit right click, you will see the open PowerShell window here. It might be command prompt for you. It does not matter in our case. So I'll just hit PowerShell and this will open up my PowerShell. The usage of PHREEQC is by simply typing PHREEQC. If I were to just press enter, it will state how it is typically supposed to be used if we just use the command, or we can also just write the name of the input that it currently suggests. I'm going to click cancel. I'm going to cancel this operation by pressing Ctrl C to cancel. Yes, so Y. And I'm just going to do the regular method of using this syntax. So the syntax goes PHREEQC, and then our input file is going to be tutorial01.pqi. So I'm going to drag this over here as this, or I could remove all this and just type tutorial_01.pqi, since I am already in the directory that I'll be running this in. It is important that you are in the same directory as the database file, since it will make it easier for PHREEQC to locate the database. We can run this as is. If we were to run it, it will append a .out at the end of this name. I do not like that personally, so I'm just going to state tutorial01.pqo. And finally, we can insert the database, but we do not have to because we already mentioned what database we'll be using. If you do not specify on the terminal, and if you do not specify on the file itself, PHREEQC is simply going to use the default database, which is PHREEQC.dat. If I press enter now, PHREEQC will run, and it tells me that the input file was the PQI file, the output file is PQO, just like how I mentioned over here, and that because I use the database keyword, the default database and the database syntax over here will be unused, and instead my database was Lawrence Livermore National Lab database, and this was simulation 1, and this is finished. To view my output file PQO, I will just double click it, and here's my output. If we scroll down to where it says beginning of initial solution calculations, we can see that our solution consists of chlorine and consists of sodium as one molality for both. If we use 2 kilograms of water while keeping the moles same, then the molality would have been 0.5. Other properties are given below, such as the pH, the PE, the mass of the water, which is 1 kilogram, the temperature, which is by default 25 degrees Celsius, as well as other things. And over here is a speciation. So this states the calculated species, as in the forms that each of these compounds are in, so or ions are in. So for example, hydroxide has a molality of 1.462 e to the negative 7, whereas sodium has 1 molality, so 1 moles per kilogram of water. And here are the saturation indices. These represent whether, so this column over here represents whether something would be dissolved or not. So for example, sodium, or to be precise, halite. Halite, the chemical is sodium chloride, but it is called halite. So for halite, the saturation index is negative, indicating that if we were to add more sodium chloride, it will simply dissolve, or in other words, whatever sodium chloride we have is going to remain dissolved. And that's the end of our simulation. With that, that was our first introduction to PHREEQC.